Welcome. If you've ever wondered how Linux actually gets online, you're in the right place. Over the next few slides, we'll walk through network configuration from the command line, building up just 4 core ideas: IP addressing, the modern tools like IP and nmcli, DNS for name lookups, and routing to direct your traffic. By the end, you'll be able to connect, configure, and troubleshoot a Linux machine with confidence. Here's the roadmap for our journey. We'll start with the absolute basics: IP addresses, subnets, gateways, and DNS, all explained in plain language. Then we'll look at network interfaces and how to inspect them, move into viewing your current config with tools like addr and iproot, and learn how to actually set an IP, both statically and with DHCP. We'll wrap up with DNS and host names, and finish strong with troubleshooting using ping and traceroute. So let's start with those fundamentals. Honestly, almost everything about getting a Linux machine online boils down to just 4 ideas. Your IP address is your machine's unique identity on the network, something like 192.168.1.10. The subnet mask tells your system which addresses are next door versus far away. The gateway is the door to the outside world, usually your home router, and the DNS server is the phone book that turns names like example.com into actual IP addresses. Keep these 4 in mind. Everything else builds on them. Let's zoom in on that first idea, the IP address itself. Take 192.168.110/24 as our example. The first 3 numbers, 192.168.1, are the network part. Every device on this local network shares them. The last number, 0.10, is the host part, unique to this one machine. And that /24 on the end, it's the prefix, telling you that the first 24 bits belong to the network. Same neighborhood, different house numbers. Now, where do those addresses actually live? They live on network interfaces, the connection points your Linux machine uses to talk to the world. You'll usually see a few familiar names. Low, the loopback, which is the machine quietly talking to itself at 127.0.1. Then etoy 0 or enpi 3 for a wired Ethernet cable. LAN or WLP for Wi-Fi. And virtual ones like Docker 0 or VRBR 0 that show up when you're running containers or virtual machines. So how do you actually see those interfaces on your own machine? The modern tool for the job is simply called IP, and the first command worth memorizing is addr show. It lists every interface along with its assigned addresses. Here you can see ENP up has a MAC address and holds the IP 192.168.1.10 on a 24 network. From the same family, IP-link tells you whether interfaces are up or down, and iproot reveals how your traffic finds its way out. 3 small commands and you already have a complete picture. Now, if you go searching online, you'll still bump into older commands that have been around for decades. And they mostly still work, but they're being phased out, where tutorials show ifconfig, reach for addr instead, where they use root-n, its IP route. For managing whole connections, nmcli is the modern Swiss Army knife. That's something the old toolkit never really had. And for DNS lookups, dig or resolvistol have replaced ns lookup. Same ideas, just sharper tools. Speaking of addresses, how does your machine actually get one? There are really just 2 paths. With DHCP, a server on the network, usually your router, automatically hands your machine an address the moment it connects. That's perfect for laptops, phones, and most everyday clients. Static means you assign the address yourself and it never changes, which is exactly what you want for servers, printers, or routers, things others need to find reliably at the same spot every time. So how do you actually configure all this in practice? On most modern Linux systems, the tool of choice is nmcli, the command line interface for Network Manager. A quick nmcli device status shows you what hardware you have. Connection show lists your saved profiles, and connecting to Wi-Fi is honestly just one line with the network name and password. The reason it's worth learning: Changes stick across reboots. It handles Wi-Fi, VPNs, and static IPs all in one place, and it's already the default on Ubuntu Desktop, Fedora, and RHEL, so there's nothing extra to install. Let's put nmcli to work with a real example, assigning a static IP. With one conmod command, you tell Network Manager 4 things: the address and prefix you want, like 192.168 50.24, the gateway, which is just your router, the DNS servers that translate names into addresses, and finally, that the method is manual rather than DHCP. Then conup applies it. That's your static IP, persistent across reboots, no config files to hand edit. On Ubuntu server, the approach shifts a little. Instead of nmcli, you describe your network in a YAML file called Netplan. Same 4 ideas you already know. No DHCP, a static address with its prefix, a default route through the gateway, and a couple of DNS servers. To apply it safely, run sudo netplan try. It rolls back automatically if you get locked out. And once you're happy, sudo netplan apply makes it permanent. Just mind your indentation, because YAML is unforgiving about spaces. Now that your machine can reach the network, it needs to translate human-friendly names like dargslan.com into the IP addresses computers actually use. Linux checks a few places in order. First, ja, etc. sat hosts, where you can handwrite name to IP mappings, then systemed resolved, the modern resolver running on most distros, which looks up the DNS servers listed in us etc. resolved conf. To see what's active, run resolve.tl status. And when you want to test a lookup directly, digdargslan.com shows you exactly what DNS is returning. Once a name resolves to an IP, your machine has to figure out where to send the packet. And that's the job of the routing table. Run iproute, and you'll typically see 2 lines. The first is the default route. Anything not matching a more specific rule gets handed to your gateway, usually your home router at something like 192.168.1.1. The second covers your local subnet, traffic destined for neighbors on 192.168.1.24 stays right on the local link, no router needed. When something breaks, these 6 commands will solve most of your problems. Start with ping to see if a host is even reachable, then traceroute to find where packets get lost along the way. Use dig when you suspect DNS, and curl-i when the network looks fine, but a web service isn't responding. And on your own machine, ip-a and ip-r confirm your address and routes, while s-tulpen shows exactly which ports are listening. Now here's how you actually use those commands together. Work outward from your own machine one layer at a time. First, is your network stack alive? Ping 127.1. Then check you've got an IP with IP addr. Can you reach your router? Ping the gateway. Can you reach the internet? Ping 1.1.1.1. And finally, does name resolution work? Ping a domain. The first step that fails is exactly where your problem lives. So if 1.1.1.1 works, but a domain doesn't, your connection is fine, it's DNS. Following that same logic, here are the 4 problems you'll hit most often. No IP address usually means the interface is down or DHCP didn't answer. Bring it up with IP link set and check your DHCP client. If you can ping IPs but not names, that's DNS, just like we said. Peek at, etc. resolve.conf or run resolves.tl status. No internet at all? You're probably missing a default route, so check iproute. And if your changes vanish after a reboot, you used a temporary command, reach for nmcli or netplan to make it stick. That last point deserves its own moment because it trips up almost everyone. When you run something like addr, the change happens instantly, but the kernel forgets it the moment you reboot. Think of it as writing on a whiteboard versus saving a document. The ip and ifconfig commands are fantastic for quick experiments and debugging, but for anything you actually want to keep, reach for nmcli, netplan, or the proper config files. Those write your settings to disk, so they come back every time the machine starts. Here's a little cheat sheet you can keep nearby. 9 commands that cover most of what you'll do day to day. The left column is your IP family for inspecting and tweaking interfaces. The middle column handles connections with nmcli and DNS lookups with dig. And the right column rounds things out: routing, DNS servers, and open ports. Learn these 9, and you can troubleshoot just about any Linux network problem you'll run into. So let's pull it all together. 4 core ideas carry you through almost every setup: an IP address, a subnet, a gateway, and DNS. Reach for the modern tools: IP instead of ifconfig and nmcli, or Netplan instead of those old init scripts. Make your changes persistent so they survive a reboot. And when something breaks, debug in layers, ping outward step by step. And the first failure point is your biggest clue. And that's really the heart of it. Know the basics, and you control the network. With just IP, nmcli, and Netplan in your toolkit, you can configure, troubleshoot, and fix almost any Linux system you'll ever touch. If you want to go deeper into Linux, networking, and DevOps, head over to dargslan.com for courses, cheat sheets, and CLI tools. And if this helped you out, please subscribe, like, and share. Thanks for watching. Now go break something and fix it.